Hi, welcome to this video. In today's video, I'm going to do this problem. Suppose this sequence a sub 0, a sub 1, a sub 2, and so on is an increasing sequence of non-negative integers such that for all integer n, there is a unique triple ijk such that n is an integer equal to a sub I plus 2 times a sub j plus 4 times a sub k. Find a sub of 1998. This is International Mathematical Olympiad shortlist of 1998. Okay, is written on the form of the generating sequence. Okay, so I can think about the generating function. Also, we can think about convolution of the product of the series. Okay, p of the x as a convolution form. Px equal to the series of a to set p of the x equal to the series of the x to the a sub k as a convolution form series. Okay, the k goes from 0 to infinity. Okay, so this one I can rewrite it as a px squared equal to the sum of x to the a sub k goes from 0 to plus infinity, and also I can rewrite px to the fourth equal to the series of x to the fourth sub a k goes from 0 to plus infinity. Okay, so now this one I can do the product of these three terms. So the product of these three terms, write this product as k goes from 0 to plus infinity. Okay, a sub I. Okay, so this one, as you see here, so this product can be written on this form. So I will have I goes from 0 to j. Okay, j goes from 0 to k goes from 0 to plus infinity. Okay, so this one is sub I. Okay, so this one, as you see here, we have the unique triple. Okay, we have unique, we have one combination of this one. So this one, since we have this arranged in order, is increasing sequence, so I has to be like this. I strictly inferior or equal to j. So since we have this term is written in terms of n, okay, so this means n is always superior than kji. Okay, so in this range, so this one I can replace this one by n in terms of n, and this one sum has to be written in terms of n as well. Okay, so we have one combination in this range now. So this one has to be written on this form. So n goes from 0 to plus infinity. Okay, n goes from 0 to plus infinity. Converge series to 1 over 1 minus x. This is geometry series. Okay, since we have this one is converge series. Okay, so now equal to this one 1 over 1 minus x. Okay, so this one I can write this one p of x on this form 1 over minus x multiplied by p of x. So now I can write p of x on this form, px equal to 1 over 1 minus x multiply 1 over p of x squared multiply p of x squared. I'm just dividing both sides by p of x squared multiplied by p of x to the fourth. Okay, so also I can write this one p of the x squared multiply by p of the x to the fourth, p of the x of eighth I'm just replacing x with x squared, okay? So I will have 1 minus x squared. This one I can rewrite it on this form, px squared multiply p of x squared multiplied by p of x to the fourth equal to 1 over minus x squared multiplied by p of the x to the 8th, okay? I'm just dividing both sides by p of x fourth multiplied by p of x to the 8th, okay? I'm going to replace the second equation into the first equation. This one, by doing the reciprocal, by doing the inverse of this one, x to the square, 1 minus x squared divided by 1 minus x multiplied by p of the x to the 8th, okay? So I'm going to simplify this one. This one equal to the 1 minus x multiplied by 1 plus x, okay? I will have 1 plus x multiplied by p of the x to the 8th, okay? So now, this one I can write it on this form, p of the x equal 1 plus x multiplied by p of the x to the 8th. I can also replace p of the x by p of the x to the 8th, okay? I'm going to use this technique of the calculation to find the product, okay? 1 plus x to the 8th multiplied by p of the x to the 8th square, okay? 64. So this one, I'm going to replace this one into p of x to the 8th, okay? So this one, p of the x equal to 1 plus x multiplied by this one, 1 plus x to the 8th multiplied by p of the x to 64th, which is 8 to the 64th, which is 8 to the 2, okay? Also, I can write also p of the x the x 8 2. I'm going to also to put the x, I'm going to replace x 8 to, I'm going to calculate p of the x to the 8th square, okay? So I will have 1 plus x to the 8th square multiplied by 1 plus x to the 8th to the 3 multiplied by the p of the x, okay? 8 to the 3, okay? What I'm going to do now, I'm just replacing p of x to the 8th into here, okay? So I will have p of the x equal to 1 plus x multiplied by 1 plus x to the 8th multiplied by 1 plus to the 8 x to the 8th square, okay? Multiplied by 1 plus x to the 8 to the 3 and so on, okay? Now I will have nice products here. I will have a product of this one. So 1 plus x to the 8 to the k. K goes from 0 to plus infinity. In this step, we have the same term, the same sequence, p of x equal to the sum of x to the a sub n. N goes from 0 to plus infinity. equal to x to the a sub 0 plus x to the a sub 1 plus x to the a sub 2 and so on until you get the last term. So since we have this increasing sequence, okay, so we have the lowest term. This is the first term is a lowest term, the second term is the next term, the third term is a third term. We have the same series, is written on two different forms, okay? The first form is written on the sum form, which is x to the a0 plus x to the a1 plus x to the a2 and so on until you get the last term a sub a to the n, okay? So this one will get this one series is increasing series, okay? We have this term is increasing in order. So this one we have a lowest term, which is x to the a sub 0, and the second term which is greater than the first term is sub 1 and so on, okay? In the same time, this series is written on a product form, okay? Plus x exponent to the a to the k, and we're going to distribute this one. It is given as 1 plus x multiplied by 1 plus x to the 8 multiplied 1 plus x to the 8 squared and so on, okay? I'm going to match the numbers. Since we have these products are equal to each other, I'm going to match term by term, okay? So I'm going through term by term. I'm going to distribute this one. If you distribute number 1, if you distribute number 1 of first term by the one in the second term, by the one in the third term, by the one in the fourth term, and so on, is giving you always number 1, okay? This is the first choice that I have. I'm going to write this one on the specific form which I want, okay? So the second choice, I'm going to multiply this x multiplied by the second term by 1, which is x, and then I'm going to multiply this x by the third term, by the 1 is located in the third term, is giving you x. If you multiply the x into the fourth term, the 1 in the fourth term is giving you x. And if you multiply x into x by the 1 in the last term, is giving you always x. X is written, I can write down x on this form as well. X to the 8 to the 0, okay? This is the second choice that I have now. So I'm going to multiply 1 multiplied by x to the 8th, okay? So if you multiply in the 1 by the x to the, if I multiply in the x to the 8th, multiply by 1 in the first term, multiply by the 1 in second term, multiply by the 1 in the third term, multiply by the 1 in the last term, is giving you always x to the 8, okay? I can write down x to the 8 on this form as well, 8 to the 1, okay? So this is the third choice. I'm going to do the fourth choice. Fourth choice, if I multiply x by x to the 8th, multiply the x to the 8th by the 1, and then third term is 1 until you get the last term. I'm always getting this choice. So x to the 8 to the 0 plus 8 to the 1, okay? 8 to the 0, that's mean 1 plus 8 is 9. That's mean x to the 9. X, if you multiply x by x to the 8 is given to x to the 9. I can write down on this form as well, okay? The term there is coming after, okay? If you multiply this one, x to the 8 to the 2 by 1 is giving you x to the 8 to the 2, and so on, okay? So I'm just doing the first few terms in order to see how this sum looks like, okay? I'm going to match the numbers. I'm going to do this one on this form. Well, I'm transferring the product form into the sum form, which is written on the previous form. I'm going to match the numbers, okay? I have this one, a0 equal to 1, okay, as you see here. So a0 equal to 1. In the second term, I have e sub 1, as you see it here, equal to the 8 to the 0. In the same time, I can write number 1 on this form as well, 2 to the 0. In the third term, I have a sub 2 equal to the 8 sub 1. I'm matching the numbers, okay? In the first series, in the second series. I'm matching the number from the first series and the second series. So now I have number 2 is written on this form as well, 2 to the 1. Okay, so I have the third term, a sub 3 is written on this form, 8 to 0 plus 8 to the 1. Number 3 is written on this form, 2 to the 0 plus 2. Now for the fourth term, to the 1, I have 8 to the 2. Number 4 is written on this form. Okay, 2 to the 2. There is a kind of relationship between index, okay, of base 2, okay, and the sequence of the base 8, okay. That's what I see here. So now, if claim integer n, non-negative number n equal to 2 to the k1 plus 2 to the k2 plus 2 to the k3, 2 to the k4, and so on until you get the last term, k to the n. Notice here k1 is smaller than k2, and so on until you get the last term, because we have increasing sequence in order. Okay, we have these numbers in order because we have increasing sequence. Okay, so now since we have this form written, since we have this relationship between the index and the sequence, I can write also a sub n equal to the 2 to the k1, because we have the same exponent as you see here, 8 to the 0, 2 to the 0, 8 to the 1, 2 to the 1, 8 to the 0 plus 8 to the 1, we have 2 to the 0 plus 2 to the 1. Fourth term, 8 to the 2, and have the, and for index, we have 2 to the 2. So there is a nice relationship between the index, okay, and the sequence a sub n, okay. So n equal to the 8 to the k1 plus 8 to the k2 plus 8 to the k3 plus 8 to the k4, and so on until you get the last term, 8 to the kn, okay. A sub n, since we have this relationship between integer n of the base 2, and we have the sequence a sub n of the base 8, put 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus 2 to the 6 plus 2 to the 7 plus 2 to the 8 plus 2 to the 9 plus 2 to the 10. Okay, since we know this information, 1998 equal 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus 2 to the 6 plus 2 to the 7 plus 2 to the 8 plus 2 to the 9 plus 2 to the 10. If you calculate, this one is giving you exactly 1998 on this one. Since I have this information, 1998 is written on this form, I can also rewrite a sub 1998 equal to 8 to the 1 plus 8 to the 2 plus 8 to the 3 plus 8 to the 4th. So a sub 1998 is written on this form as well. A sub 1998 equal to 8 to the 1 plus 8 to the 2 plus 8 to the 3 plus 8 to the 6 plus 8 to the 7 plus 8 to the 8 plus 8 to the 9 plus 8 to the 10. Okay? So now, if we calculate this one, is giving you 1998, okay? If you calculate this one, is giving you this form. I'm going to rewrite 8 on this form. 2 to the 3. I'm going to take 2 to the 3 outside as a multiplier, and then multiply by to this sum. Okay, and multiply by this sum. This sum is 1998 minus 1. Okay, so as you see here, a sub 1998 equal 2 to the 3 multiplied by 1998 minus 1. So a sub 1998 equal to the 3 multiplied by 1997. Okay, I have done with this problem. Don't forget to support us by subscribing. Thank you for watching. I will see you in next video. Bye.